Welcome back, Wildcats. Today we are going to be looking at two different types of inverses. Now I know what you guys are thinking about. Yesterday we only did one, so how come? Why are we doing two types today? And well, the answer is quite simple. And if you look at quadratic and square root inverses, the reason we're doing two types today is, as you will remember, quadratic and square root functions are opposites. They are inverses of each other. Linear equations are inverses of other linear equations. But since quadratic and square roots are their own inverses, it makes more sense to do them together. So the inverse of a quadratic function is a square root function. The inverse of a square root function is a quadratic function. So let's take a look at an example of exactly how to do this. That's the wrong one. Of exactly how to do this with mathematically, algebraically. So here's an example. Let's say you remember the steps. Step 1, 2, 3, and 4. These 4 steps, we can use them with any type of inverse, not just linear. So this works for all inverses, these 4 steps. Let's say our function, though, is f of x equals x squared plus 3. So if we switch f of x to y, and then we reverse where x and y are, we can now solve for y. We start by subtracting 3 because PEMDAS backwards says addition comes first. That gives us x minus 3 equals y squared. The opposite of squared is square root. So what we have here is the square root of x minus 3 equals y. Keep in mind that when you take the square root of both sides, you're taking the square root of all of both sides. All we have to do from here is to change y to f of x, and for some reason I put it as g of x, so that is an error. That shouldn't be g inverse, that should be f inverse of x. Once again, I have never made a mistake. So now we can see where all these steps are. Switching f of x to y, changing x to y, solving for y, and replacing it with the proper letter. However, algebraically is not the only way we can see an inverse. So let's take a look at what inverses look like as a graph. So step 1, we always want to start with our linear graph. So we're just going to have y equals x, because that is the line that we're going to reflect everything over. After that, if we graph our function, let's say that the function we're graphing is x squared, that would look like this. Notice I went ahead and made the y equals x line dotted at this point. After you've graphed both of these, if you graph the inverse, which is in this case just square root of x, you can see how the inverse is just flipped over the line y equals x from the original equation. Do remember, though, with the square root function, that bottom half doesn't exist. The bottom half does not exist. So you have to restrict the domain of your quadratic to have a function for the inverse. We talked about that in the previous homework assignment. So, a couple of major takeaways here. Quadratics, square roots, inverses of each other. Opposite of squared is square root, and on a graph, all you're going to do is reflect over the line y equals x, and you have a graphical representation of your inverse. So guys, that's everything that's within 1.4b. As you can tell, this was a very short video because square root inverses and quadratic inverses go very quickly once you already know how to do linear. So Wildcats, good luck with your homework. And as always, you can find the help on YouTube on my channel if you need additional help, or you can find me either in class or shoot me an email.